So in this video, we'll be going through strategy design pattern. We have already looked into decorator design pattern and factories in Java. So in this video, we'll talk about what's a strategy and how it is implemented in programming languages, and along with a real life example, like when to use a strategy pattern. So let's get started. First of all, what's a strategy? So strategy is nothing but a set of plan that helps us to achieve a goal. So you would have heard this term a lot in sports, where the sports person follows strategy to consolidate victory for him or her. So similarly in programming languages also we have certain steps to get to the response corresponding to a request. So those ways that we define in our code is simply a strategy implementation. So very basic example and a very common example is when you are making a payment on any uh, e-shopping platform. So there are various ways to make payment. For example, there is a credit card using which you can make payment. PayPal is there, Bitcoin is there. So a lot of options are available. So if you think that your request is same in all of these cases, that is you want to make payment. You want to make payment. Sorry. And your response is also same. That what you want to achieve is also same. That payment should be done. Payment should be done. This is the ultimate goal. But the way you reach from here to here can be different. It can be via credit card, can be via UPI, and a lot other example like options that will help you to reach at this goal. So a very common implication of a strategy pattern is when your request and response are same, but the way you achieve them is different. Then you can think of using strategies. Using strategy, you also ensure that your code follows a single responsibility principle, that each of these implementation do their own task without affecting any other component, and also it is highly extendable. What you can do whenever a new like strategy is there, you can simply define its behavior and add it to your code without touching the existing flows. So we'll see what are various components in strategy. So the first thing you start with is your request. So this is the first component, and this request contains some data. This request has some data, and now this data goes to strategy evaluator. So strategy evaluator is nothing but it uses this request data to decide what is the strategy that is required to achieve a response out of this request. So in our case, this data can contain like instrument detail. So this can contain instrument detail, and based on this, the evaluator will give us a response. For example, it gives us credit card strategy. It means for this, the instrument was credit card, and we need to have our credit card strategy executed in order to get the response. Now, this strategy is sent to a factory. What this factory contains is nothing but strategy to its implementation mapping. Strategy to implementation mapping. So based on this strategy, we fetch its implementation, and then we simply execute this strategy and we get the response. So this is a common flow that is present over all the strategy patterns that we define. So we'll go through a problem statement and its solution using the strategy pattern. So on various e-commerce websites, what we see, we are provided with some offers or discounts. So these offers can be of different type. For example, a regular offer for like a offer for a user that is coming to shop for the first time, and for a user that is part of some membership, for example, VIP membership. So all of these categories of users have different set of offers. So at the beginning, we have simply our fetch offers request. we have our fetch offer request, and at the end we have our offers. So the request and response is same for any of the user that we are having here, be it of any type. But the way we like calculate our offer is different for each kind of user. So it gives us a hint to use strategy pattern, and also the problem statement mentions that the code should be extendable and we should not be modifying existing code if we get to have any other set of users here. For example, some set called delight, where user making some X number of payments, like X number of orders are given different offer. So this flow should not be disturbing the existing flows. So we'll see like how our evaluators and factories will be defined here. So our evaluator will have simply nothing, but it will, based on the request, it will give what kind of user it is. So we may get this data in the request itself, or we'll have to calculate this based on the request. That depends upon the use case. But all this logic will go in this evaluator. So, like post getting this strategy from this evaluator, we will pass this strategy to our factory. Our factory contains nothing but these strategies, and corresponding to these strategies, we have the implementation. So fetching from this factory the implementation, we will execute that strategy here. This factory contains that strategy to implementation map. Now we'll see what's the structure of these strategy, like how they are written in the code. So a basic like factory follows a very common structure. At the top, we have this interface. This is a functional interface, meaning it has only a single method that is executed. You can name this function anything based on your context. For simplicity's sake, here it is execute. So it simply produces a response and it has a request. And we have concrete strategies out of it. So these strategies are the one which implement this interface, providing us the response corresponding to the request. So in our case, it can be VIP offer calculator, or maybe first time user offer calculator. So these are the concrete strategies that we can have. And if we get into the code here, so first of all, we'll see how we are defining our evaluator here. So the evaluator, as we saw in the example, it simply provides us with the strategy that we want to use. For example, if the request contains the user type, it checks if the user is a first time user. It simply returns that the strategy is to execute first time offer calculation. And if the user belongs to VIP membership and its purchase amount is greater than 500, then the response from the evaluator is that it is a VIP strategy execution that needs to happen here. And otherwise, it's a regular user, and we need to have the regular strategy. Now, the response of this evaluator goes to this factory, where based on the response, we have different strategy objects, implementation objects that we provided back to the code, like our main code to execute. So for regular, we have the regular discount strategy, and for the first time user, we have first time discount strategy. For VIP, we have VIP discount strategy. So we are using simple switch case here, but in like in our previous videos, so we can implement the factory in a better way. So for sake of simplicity, I am keeping it like this. And also we will get back to evaluator implementation as well. This can also be made better, but for like simplicity sake, it is just if else conditions here. Now we move to our simple, like what we saw in strategy. So if we go according to the pattern, we'll have a topmost interface which have the single method. At the end, we want the discount out of the amount. So this is the like functional interface that stays at the topmost level, and it has the input as the amount, and it will give the discounted price. And we have the first implementation of this like interface here, which is the regular discount calculation. So for a regular user, we are simply providing 5% discount and the implementation stays like this. And on the second, we have VIP discount, which also implements this discount strategy interface, and it gives 20% discount. And for first time users, we have a 10% discount construct. So all of them are implementing this interface itself, and all are defining the discount calculation in their own way. So if we move back to our this slide, here simply the request contains the user type for our example. It may or may not be possible that this data is directly present in the request. We may need to make depending upon the request, we may need to have some logic defined in our evaluator to fetch the strategy. Now, based on this user type, our strategy evaluator basically decides one of the given strategies, that is VIP first time or the regular user. And now this data is supplied to the factory that we saw, that switch case implementation, and it will simply give the implementation. Like if it's a first time user, will give the first time discount strategy implementation. Discount strategy implementation here. So this is nothing but an object. If we saw in the code, this is nothing but initialize object. Now this will have the apply discount method. So for example, the object is named as obj. Then we will simply call the object dot apply discount. Apply discount on the request amount. Suppose that amount is present in the request itself, and we get the our discounted amount as the output. So this is the discounted amount that we get from this application. So we saw that the strategy evaluator that we implemented had if-else conditions in it. So you would be thinking if in future we want to add new strategy, then we'll have to go and change the like evaluator implementation, which violates the open close principle. So you are right in this case that we are using if-else, but in like more complex cases and for real life cases, what we do is we use chain of evaluators. So this chain of evaluators will have evaluator for each kind. So there will be one evaluator there, and there will be a next evaluator that will be chained to this, and there will be a third evaluator, and on all on like each of this there will be some logic. So if any of this evaluator is able to decide the strategy, we simply break out of this chain. So this method is also known as chain of responsibility design pattern. Chain of responsibility. This is another design pattern that is very common, and we can use this pattern, and whenever we want a new strategy, we can define how the evaluator functions in that case and add that evaluator to this chain. Uh, there are some constraints in this chaining logic as well, which we will pick when we are going through this chain of responsibility like design pattern. For this video, we'll be stopping here. Thanks for watching, and please do subscribe. Thank you.